Hey guys, welcome back to my YouTube channel, and today we're talking about chapter 16, serialization and file IO and saving objects and text. Now let's summarize the chapter, what is really happening. So we're talking about an object, and what really happens. An object is created on the heap and its state, which means that the value stored in its instance variable make it unique from other objects of the same class. When we serialize an object, like saving a full object with way and height values, the variables values are saved into a file which is for.se, right? Like foo.se, like in here we have the game character, and this is what they are talking about. The variable is saved in foo.se. Now, what exactly is an object state? So an object state, it's all about the information that it holds that makes it different from other object, which comes from its instance variables. For example, a car object might include an engine, right? And a list of tire object as part of its state. And each of these objects contains their own data as well. So when we save the car, we need to save not only the car's own data, but also the data inside the engines and tires. So we need to have the data and engine and tires at the same time, since they are part of the whole state, right? So this ensures that when we restore the car later, we can get back any object with all the same information as before. And even though it will be stored in a different location in memory, we'll still get it. What does it mean when we say an object is serialized, right? So when an object is serialized, it's all the other object that refers to through its instant variables, and it is serialized automatically. So it includes not only just the directly connected objects, but also any object that those objects refer to, and so on. So this of the connected objects, it is called the object graph, and in Java it is serialization that saves the entire graph, right? Then if we want, sorry, then if we want our class to be serializable, implement serialization, what is going to happen is that the serializable interface is called a marker interface because it doesn't have any methods we need to implement. So its main job is to mark a class as something that can be saved to a file or sent over a network, right? So when a class implements serialization, it tells Java that the objects of that class can be turned into a series of bytes and later restored. So deserialization is the opposite of serialization. So also if a class parent already implements serialization, then the child class is automatically serializable. So even if it doesn't say explicitly. So in the code example, there's a class called square, and they implement serialization, meaning the objects of this class can be saved to a file. So the class has two fields, which is the width and the height. And in the main method, we create a square object and use the file output stream and object output stream to write the object to a file called foo.se. Then the write object, my square line, is where the serialization happens. And if the square class didn't implement serializable, this line would throw an error at the runtime. So let's go to a certain code. As you can see here, I'm creating a public class. I'm naming it game character, and I'm implementing the method serializable, right? Then private int power and private final string type and the weapons and all that, right? I have the weapons in my game, I have the power, I have the type, and I have the main saver, game saver.test. So I'm creating three game character objects with different stats and weapons, right? Which are these that you see, different states and weapons. Then I'm imagining it, we modify their state here during the gameplay. Then we serialize the game character objects to a file. Then we create an object output string to write the objects to game.ser, right? It's going to create a file called game.ser. Then we write each game character object to the file, right? Like 1, 2, 3 as they show here. Then we close the screen, which is um, os.close. Then I catch the IO exception. We handle the exceptions related to the file writing or serialization. Then deserialization, the game character objects back from the file, right? Then we create an object input stream to read the objects from game.set. Now, without saying more, let's see what output we get. We get in this following output. So I need to uncomment something here. Let's see if I uncomment this. So the Java, no. This one, why am I uncomment? Comment. Now let's play this. Still getting the same error. What? Okay, let's play it again. Symbol. Okay. Comment. Let's play it again. Getting nothing, right? So that's how it is. But the final output that we get here is this. Right? You have the start button, you have the store button, and this is called a GUI, a graphical user interface made with Java. Now let me go on with my notes. So I'll go through the important part only. So when writing a string into a text file, so saving data into a Java can be done in different ways, right? Depending on what your program needs. One common method is called serialization, which lets you save and reload the entire objects between runs of a program, but sometimes you need to save your data in a plain human readable text file, especially if other programs need to read it. For example, a Java web program might collect users' input and save it to a text file, right? Which means that someone can open it later. Then in these cases, instead of saving the full Java objects, we save our text using a file writer. So in our code example below, it shows how to write a simple string to a file using a file writer. In the main method, we have a file writer, right? Object is created for a file named foo.txt. Then the write method is then used to write the text hello foo to that file. After writing the close method, it is called to make sure that the file is properly saved and closed. Then a try catch block is used to handle errors called IO exception. In this case, something goes wrong while writing compared to saving the objects with object output stream, writing plain text and all of that. So yeah, that was my chapter 16. Here they just show you how we write the file. As shown in my notes, what we do this is that in my example is that we write a simple string to a file using file writer, and the main method is a file writer object when it is created for a file named foo.txt. Then the write method, what it does, it is used to write the text hello foo to that file. After writing, the close method is called to make sure that the file is properly saved and closed. Now let's see. What are we doing? We are creating a file writer to write a file named foo as explained in the notes, and we write a string to the file which is hello foo. Then we close the writer to save the changes. After that, we inform the user that the writing was successful. Now let's play it and see if we get the foo.txt. Data has been written, which means the data has been successfully written, the file foo.txt. Now let me see if I have my foo.txt. There we have hello foo. So what happened is that the write method was used to write the text hello foo to that file, and after writing, the close method is called to make sure that the file is probably saved and closed. Then we use a try catch block method, which is used to handle the errors called IO exceptions, right? So in this case, something goes wrong while we write our code. Compared to saving the objects with objects output string, we are writing a plain text with a file writer, and which is simpler and easier to read. So this is the output that we get. Now let's go to the second node that we get. Now we go to our text file example, e-flashcards. What are e-flashcards? E-flashcards are like regular flashcard used for studying but on a computer. Each card has a question and an answer to help memorize facts. So in this Java example, we create a small program that lets you make and save review flashcards. So there are three parts, which are the cards, the quiz card, and the what is this? Let me see. I'm not reading nicely. There are three parts, right? Which is the quiz card builder, which lets you type in questions and answer and save them to a file, right? Then we have a quiz card player that lets you open the file and go through the cards. And the quiz card is a simple class that holds the question and answer for each card. Now let's see if we have that. What page is this? Page 562. Do I have 562 here? Okay, there's the quiz card. So what am I doing? I'm creating a class called quizcard. I have the string which is question, private string, and I'm creating a constructor to initialize the question and the answer. Then I'm using the getter for the question method. Then I'm using the getter to get and return my answer. Then I have the main file which is quizcard.player. What am I doing? I'm requiring a public class called quizcardPlayer. I'm initializing the current card index and the private quiz card current card, and the text area, the JFrame. Remember, the JFrame we use when we use it for GUI, graphical user interface that we want to build, right? Then we have our public static void to play our main file. Inside our void, we have our panels and our fonts on how we want the framework of the app, to display, and the titles and the buttons on how they are going to display also. So the text will be show question, and we have event listeners too. Without saying a lot, I'll just play this and we see what we get. So now what we are seeing here is called a graphical user interface quiz card player. So in here we have the file and we just have a blank box with the button show the question. So right now there's no question because we didn't implement the question. It says we even get an exception in thread. AWT event queue cannot invoke because the card list is null, right? Yes, it's null. But in return, what do we get? What is the capital of France? Paris, and the questions, all of them. Let me just replay this and see what we get. Stop and rerun. Still doesn't show the questions. Quiz card player because AWS is down. It's fine. Now we go to our other questions. Part 2, right? We're creating a scroller method which makes and takes the JText area and wraps it inside a JScroll pane and configuring the scroll pane to always show a vertical scroll bar but never show a horizontal one, which improves the usability when entering long text. Then we are creating a text area method and which returns a configured JText area with line wrapping and a specified font, ensuring the text area, which is visually consistent and easy to read. Then the next cut method takes the text from the question and answers the areas. A new quiz card object and adds it to the list of cards. I thank you for viewing my YouTube channel and I hope you learned something from what I've said in my notes. Hope you click that subscribe button to view more of my content.